A noisy channel model ranks SymSpell candidates before they hit BM25. You'll see how to connect the pieces into a workflow that ranks likely query fixes and searches with the best one. I'm Professor Pi, teaching Search and IR with simple Python. Spelling mistakes do more than look sloppy. They can steer search to the wrong documents. A noisy channel approach treats correction as a ranking problem. We don't just pick the top suggestion, we score plausible fixes by how likely the user actually meant them. That matters a lot for short queries and product names where there's almost no context. Fixing a typo into the wrong common word can make relevance worse, even if the string looks cleaner. Here's the simple plan. Generate candidates 1 or 2 edits away. Then prefer candidates that are both close and common. The noisy channel pairs an error model, how a real word could produce the typo, with a prior that favors words users actually type. For example, quick yields quick and quirk as 1 edit candidates. Frequency tells us which one is generally more plausible. We'll build a compact pipeline that shows each step: candidate generation, a frequency prior, a guarded token fixer, and a final BM25 check, so we confirm the correction helped retrieval instead of hurting it. The code is deliberately tiny, so you can map the pieces to real search logs later. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. We'll start by showing how SymSpell suggests candidates, so we can see the ambiguity we need to resolve. This snippet builds a tiny SymSpellPy dictionary and asks SymSpell.lookup for spelling candidates. Edit distance alone can leave the retriever with multiple plausible fixes, which is exactly where careless correction starts to hurt relevance. The docs create a small search vocabulary. SymSpell stores that vocabulary, and verbosity.all keeps more than the single top suggestion visible. The typo quick now maps to competing terms rather than a silent replacement. The visible output shows the candidate terms and distances, so we can see why ranking is needed before changing the query. Next, we add a simple prior so we can rank those competing candidates instead of treating them as tied. This example adds wordfreq zip frequency to choose among the SymSpellPy candidates. Treating every same distance candidate as equal makes the correction step brittle, especially when 2 words are 1 edit away. Channel score combines the candidate prior from zip frequency with the edit distance already carried by each hit. The 0.9 weight controls how much distance is penalized. Increasing it favors closer spellings, while decreasing it lets common words win more often. The visible output shows which candidate becomes the selected fix, giving us a ranked decision instead of a flat candidate list. Once we can pick a best fix, we must check that the fix actually improves search results and not just the string. This snippet checks whether the spelling decision changes the BM25 result, not just the spelling string. A typo can make BM25 ocopy get scores return weak or empty lexical evidence, so the top document may be arbitrary or driven by unrelated query terms. The snippet builds a rank BM25 ocopy index over the same docs, scores the raw token, then scores the selected best term. Comparing raw top with fixed top makes the retrieval effect visible instead of assuming correction helped. The visible output shows the top document ID moving after correction, which connects spelling quality to search relevance. Real queries contain tokens you must not rewrite. Next, we make a guarded fixer that avoids harm. This snippet turns the scorer into a safer token-level correction function. Search queries often contain product names, acronyms, IDs, and ranking features that should not be rewritten just because they look unusual. Fixed token first checks sim.words and digits, then calls SymSpellPy sim.lookup only for unknown tokens, using channel score from wordfreq for selection. That keeps BM25 intact while still correcting quick. The visible output shows a guarded corrected query, which matters because good correction should improve typos without damaging already meaningful retrieval terms. Finally, we tie correction and retrieval together for a compact end-to-end check. This example ties the noisy channel correction step directly to BM25 retrieval. The query enters as user query with 2 misspellings and 1 technical token that should be preserved. Clean query applies fixed token to each token. Then rank BM25. BM25.getScores ranks documents using the corrected tokens. This is still a tiny baseline, but the pieces mirror a real pre-retrieval stage. Candidate generation, prior-based ranking, guards, and lexical scoring. The visible output shows the corrected query and selected document, giving a compact end-to-end check before adding this pattern to a larger hybrid or RAG pipeline. In a production mapping, you would run this pipeline on a sample of logged queries. Measure whether corrected queries increase click rates or MRR before rolling out broadly. Also log which tokens were rewritten, so you can audit accidental overcorrections. 3 quick takeaways. Noisy channel correction generates candidates and ranks them by distance and frequency. Use it before retrieval when typos are common and queries are short. 1 caution. Overly aggressive rewriting can harm product names and technical tokens. So, add guards. A practical next step is a small tuning experiment. Vary the channel weight around the default 0.9 and jointly tune BM25K1 on a held-out set of search logs to find a sweet spot that improves MRR without overcorrecting branded tokens. If short practical IR helps, subscribe and watch the IR videos.